All right, I'm going to go through a quick BLAST lesson to practice shell scripting. Instead of giving you copy-paste commands on the lab, I just gave you some instructions, but I will demo it here. But it's a good idea. I think I've had complaints about this class before that it turns into very much like copy-paste, and you don't necessarily learn as much as you could be. So we're going to try to get away from that in a few of our labs. All right, so I have already logged into the ACF, and we are going to try to get that qsub command working and see if I can get an interactive session. So I can't remember our project name, so I'm just going to go copy and paste that from the course website. Let's submit that and see what happens. All right, so I'm going to see if I actually got on a compute node by typing uname and -a and seeing what we get. So that is telling me I am on ACF BC003. That is different than a login node. So that's good news. We have our own compute session now, and we requested up to an hour. So that's great. We're not, if you're still a little confused about login node versus compute node, you can go back and review our notes. But basically, there are shared computers called login nodes that everyone logs into. And from there, you request computing resources. So if everyone just logged in to the login nodes and just started like doing their work, we'd all crash into each other, and those computers would get slowed down and bogged down, and nobody would get anything done. So the goal is to log onto those computers and not do very much at all except to request resources. So what we've done here is request to be put onto a different computer to have our own CPU and RAM carved out just for our usage. So this is the proper way to do work on the ACF. Do not do work on the login nodes. They do not appreciate that. All right, great. So the next thing I want to do is go to our class project folder, which is in Luster Haven courses. So I'm going to CD to Luster Haven courses. This is called EPP 622. And I'll go ahead and go into my own directory. You should go into yours, not mine, because you won't be able to write to mine. From there, I had previously made a bunch of BLAST files for our last lesson, which is fine, but they're kind of clogging up everything. And so I'm going to move them into their own separate directory. And I already practiced this lesson, so I'm going to delete my old scripts file, and we're going to recreate it during this lesson. So to delete a directory, use rm-r. The R is for recursive. So I'm going to go ahead and just delete that directory. If I do an ls, it's gone. I'm going to make a new directory, and I'm going to call it BLAST practice. So now if we do an ls, we see our BLAST practice directory. And I'm going to move all of these files into BLAST practice. So I'm going to move cow star into BLAST practice, and then move human star into BLAST practice. Now if we do an ls, all of those files have gone away. I put them nice and neat into an organized little subfolder. This is good thing to do. Keep your files organized. Okay, so let's make a directory called script practice this time. And we're gonna do some blasting in here too, but it's really gonna be more about writing scripts. Okay, so let's CD into that directory. Now I have made some files for us to practice on. We're going to copy them from another location. So I can see on the course website that the files are in Luster Haven courses EPP 622 BLAST files. So we're in our course project directory in something called BLAST files. So right now, I'm in our course project directory, my username, and then script practice. So for me to copy those files, the relative path is copy. I'm going to back up. That would put me in my directory. I'm going to back up again, that puts me in the course directory. And from there, I have a folder called blast files with some stuff in it. I'm going to put star. I don't know what's in there. I'm going to copy it all right into the directory that I'm currently in. So now if I do an ls, I can see all of those files. I've got something called input 1, input 2, input 3, input 4, and something called platypus mRNAs. So let's take a look at these files. So we've learned this really handy head command. And this is really nice because I don't, FASTA files, they could be amino acid, they could be nucleotide. Which are these? I don't know. So let's find out. I'm just going to get the first 2 lines. Let's look at input1.FASTA. It's a protein sequence. And let me teach you something. You can use stars, wildcards, all over the place in the command line. So if I do star.FASTA, it's actually going to give me the top 2 lines of every single one of those. So input 1 looks like a protein. Input 2, also a protein. Input 3, again a protein, and input 4, also a protein. So all of those 4 input files are all amino acid sequences making proteins. So what else do I have in this directory? I have a platypus mRNA file. Let's look at what's in there. I'm going to do head on platypus. All right, so this is interesting. This one is actually a nucleotide sequence. Let me make this a little bigger in case you're having a hard time seeing. Okay, so this is a nucleotide sequence. So we learned previously that BLAST has lots of programs to help us manage different types of nucleotide and amino acid combinations. So I'm going to go get a browser window real quick and drag that onto the screen so that you can see it. Here's my little browser, and I'm going to type in NCBI BLAST. I think this is the best way to sort this out. Okay, so this gives me the 4 most common blasts. So I actually want to go from my input is a protein, so I want to blast these protein files against a nucleotide database. And since I know that my protein files are definitely coding, it would probably make the most sense to go ahead and translate that database. So in this case, it looks like tblastn is the program we want. Yeah, so tblastn, protein input, translated nucleotide database. You can also just go back to the previous lesson, which has all of the BLAST programs listed. Okay, some other relevant things I might want to know about these files. How many sequences are in these? Is this going to take a long time? So let's do a grep-c, single quote, caret, greater than. And this is basically saying search these files and count the number of times we see a greater than at the beginning of a line. So this is just a super simple command you can memorize to do to count the number of sequences in a FASTA file. And again, I'm going to use a wildcard and say I really want to know about all of my FASTA files. So in this case, it's telling me there are 2 sequences in each of my inputs. And I'm going to do the same thing for my platypus file. There's 741 mRNAs in my platypus file. So we will see if there's any overlap between my inputs and my platypus. So before we actually get to the part of running a script, let's just do one. Like oftentimes when you want to write a script, you want to build it in very small increments. So you kind of want to put all the pieces together instead of just sitting down and writing it beginning to end. That can be a little intimidating. So the first thing we can do, let's just make sure we know how to do this BLAST. If you remember from our previous lesson, you want to do module load BLAST. So it's going to give us access to the BLAST program. And then we determined that tblastn was going to be our preferred, it's going to be the program we need to do nucleotide to, or proteins against translated nucleotides. So I can do tblastn-help. I want to go ahead and pipe that to less so that we can take a look at it. And if I sort through this help document, I'm going to see that this looks an awful lot like BLAST-P. We have got all sorts of different possible flags, but some of them look very familiar, like the dash query is going to be how you specify the input file. The -db is going to be how you specify the name of your database file, the -out, the -e value. So it's looking like a lot of our commands and our flags that we learned in the previous class period are still going to work. And that is true of most of the BLAST programs. They're going to work about the same. But before I get ahead of myself, we still need to make our database. And the command for that is make blastdb. So I'm going to say make blastdb. The flag for input file is -n. I'm going to do platypus mRNAs. In this case, they are nucleotide. So I believe the command is db, no, I think it's just type and nucleotide, NUCL. So I'm trying to remember this, and I might not have it right. And indeed, it says, oh, hey, that dash type, that's not a thing. That's not a flag I know about. But looking in this usage, I can see I forgot the -db. So -db type, and then the molecule type. So I'm going to hit the up arrow, which apparently isn't working. And then I'm going to type make blastdb. So I'll have to start over typing since my history seems to be gone. -n platypus and -db type nucleotide, NUCL. Okay, so now this worked. We got the flags right this time. And it's saying building a new database using the current time, added 741 sequences. So that looks great. Next, we are going to do our tblastn. So for the query file, let's just try our input1 file. For our database, we'll use our platypus. And for out, we'll say input1 versus platypus. And this time we're using tblastn. I'm going to put that on there. And let's do an out format of 6 and just see if we get any results. So this was the it was tab delimited, very short and sweet, not a lot of extra information. Great, so that ran very quickly. And now I'm just going to use Nano to look at that. Input1 versus platypus. Don't forget to be using your tab complete, right? So in that case, I just typed input1 dash and then tab, and it completed the rest of the file name. Okay, so yes, one of our input files, one of our input sequences had some matches. And if we remember, we could run output format 7 if we wanted to get the column headers. But I happen to remember this one as percent identity. So not extremely high percent identities. And if we continue to mouse to arrow over to the right, we'll see our E values are pretty high. So these may be random matches, but that's okay because it's just an example. Okay, so I'm going to Control X to get out of there. And the next thing we want to do is we really want to start moving this into a script. So I can copy this and then do nano blast.sh. So I'm going to name it .sh because that means that that's the standard ending suffix for a shell script. So that's just going to let me know, or let anyone else know who's looking at this, that this is an executable shell script. And from here, I'm going to paste that line in. And at this point, I just want to make sure I know how to run a shell script. So starting small, increments, tiny steps, let's just save here. So I'm going to go to Control X, save modified buffer. I'm going to say yes, and I like the blast.sh. So the lesson that you went through in software carpentry is going to tell you to run shell scripts with the word bash, and that will work. So let's see that. So I already have the same output, so let's remove it to make sure I'm actually recreating it. So I'm going to remove this input1 versus platypus.blastn. Okay, so it's gone. So we're pretending like we're starting from scratch. If I run bash blast, it's quite a mouthful, and then I do an ls, I will see that my input has been recreated, so our shell script worked. And if we look, actually, we can just do a cat. So just print this to the screen. Input1. What is that? That looks like that has about the same information that we had the first time we ran it. And indeed, it should be identical because we ran the exact same commands. We just ran it through a shell script instead of on the command line. But it would be really nice, instead of typing that in 4 times, if we could instead do all of the input files at once. So let's work on building that shell script. So I'm gonna do nano blast.sh. I'm gonna put this in a comment for the time being because it's a little much. I wanna start instead by building my for loop. So I'm gonna type for input file in star, we'll say input star FASTA, and let's just echo that for now. Just, again, this is going to give us a little bit of confidence that we have constructed a for loop that will actually work. And one of the common ways is to always, ways to format a for loop is to always indent the lines between the do and the done. And that just leads to nice readability. Okay, so I've got for input file and input star FASTA. The only thing I'm going to do with that variable is print out what is that variable holding, just so we can see how the loop is functioning. So let's Control X, save the buffer, and write it out. Okay, so now let's learn a second way to execute our shell scripts. We now know about permissions. So we can say change mode. I want to give myself the user execute permission, blast.sh. And now I can just use the path blast.sh. So this is exactly the same as typing bash blast.sh, except I'm just giving it the path and saving myself a few keystrokes. So if I run that, it's doing exactly what I thought it would do. It is looping through each one of those files and printing them out onto the command line. So yay, our for loop is working. So let's go back in and work on getting the blast files, the actual blasting activity into the for loop. Okay, so going back to nano blast.sh, I am going to take this line and copy it, and then I'll go down here and delete the whole thing. Okay, so inside of our for loop, I'm gonna hit tab again and I'm gonna paste that line. Now we still have to make some alterations to this, right? If we ran this every single time it went into the for loop, it would run input 1 every time. Input 1 versus platypus, t-blast-n. Input 1 versus platypus, t-blast-n. Input 1. So that wouldn't be very useful. We want to actually use this variable. And the place where this variable would go is here. We want to replace that right there. So that's going to make sure that each time we go into the loop, we're working on each different item in the list instead of just running the same file over and over again. The other place we need to change this is in our output file. So the other problem we would have here is, let's say that we're on the last iteration of the loop and it's input for.fasta. The command that would get constructed and sent to the shell would be t-blast-n query input for.fasta platypus database out input 1 versus platypus.t-blast-n. So the output file would overwrite the original input 1 output file because we haven't changed that name. We haven't made that name reflect the fact that we're working on a different input file. What we can do is $input file right there and see if that works. So, so then you'll have input file input for.fasta dash versus platypus.blast-n. Okay, so let's write that out. Okay, and we're gonna exit. So let's try running our blast command again. Okay, in this case, it was continuing to echo, and now we can see if we got any results. And indeed, we got all of our different output files. So we have now written a for loop that successfully did a blast for all of our different files. So you could have had 100 input files or 10,000 input files, and it would have iterated through and run each and every one of them. We can go and look and see what kind of output we got. So for example, input 4, let's see if we got any. We did. We got some significant results This was human sequences blasted against platypus sequences, so maybe not that surprising that these are quite distant and not having a lot of similar hits. Yep, okay, so that is our short little lesson on shell scripting using BLAST as an example.